Hello my friends, and welcome back to the Repair and Installation TV channel. In the first major flood of the year, Interceptor 006 faced its ultimate test. Designed to stop plastic before it reaches the sea, this system captured an extraordinary 1.4 million kilograms, over 3.1 million pounds, of trash in just one night. That's hundreds of truckloads of waste, intercepted before flowing into the Caribbean Sea. The Interceptor works by guiding floating debris into its mouth, where conveyor belts lift the waste onto a shuttle and transfer it into dumpsters on a barge. Operating autonomously, it can process massive surges of river pollution day and night. This record-breaking catch demonstrates the scale of the challenge, but also the power of technology when deployed at the right place at the right time. Each ton collected means less plastic polluting our oceans. In Bangkok, the Chao Phraya River has long carried large volumes of plastic and floating waste, especially after rainfall when canals push debris into the main flow. To address this challenge, Interceptor 019, developed by the Ocean Cleanup, operates continuously to capture and remove trash before it reaches the ocean. Its operation begins with a floating barrier that guides waste carried by the current toward the machine's intake. At this point, a solar-powered conveyor belt lifts the debris out of the water and transfers it into the storage system. Sensors continuously monitor the waste flow, allowing the conveyor to adjust speed and prevent blockages. Inside the Interceptor, the collected waste is distributed into detachable containers. Once a container is full, a railing and crane system automatically switches it with an empty one, ensuring uninterrupted operation. This modular approach allows the unit to process waste continuously without downtime. By combining a guiding barrier, solar-driven conveyor, smart monitoring, and interchangeable containers, Interceptor 019 can operate 24/7, removing tons of plastic and trash daily and significantly improving the cleanliness of Bangkok's main river. Every day, tons of food waste end up in bins, but what if your leftover pizza crust could power a bus? That's not science fiction. It's food waste recycling. Instead of letting food rot away in landfills, it's collected and delivered to Geneco, where the real magic happens. Here, wasted food is transformed into biomethane gas, a clean and renewable energy source. This gas can generate electricity, fuel vehicles, and even keep the lights on while you're cooking your next meal, hopefully finishing it this time. It's the ultimate comeback story, yesterday's leftovers becoming today's energy. By recycling food waste, we're creating a circular economy where nothing truly goes to waste. Every banana peel, coffee ground, and stale sandwich becomes part of a cleaner, smarter energy cycle. So next time you can't finish your fries, don't feel too guilty. You might just be feeding the power grid. Every year, billions of pounds of carpet end up in U.S. landfills, most of it petroleum-based and rarely recycled. Aquafil has taken on this challenge by establishing 4 carpet collection facilities and a specialized recycling plant in the United States, designed to recover and transform discarded carpets into valuable new materials. The process begins with shredding, where large carpet rolls are mechanically reduced into manageable fragments. During this stage, calcium carbonate, used as a stabilizer in carpet production, is carefully removed. This recovered calcium carbonate is later repurposed for applications in the cement industry. The Seon phase focuses on breaking the chemical and physical bonds that hold different carpet components together. Precision equipment separates fibers from fillers, preparing the material for further refinement. In the third phase, the two main fibers, nylon and polypropylene, are fully separated using a proprietary sorting and purification technology. Each recovered element is then processed for reuse. Polypropylene is recycled into engineering, plastics is directed into industrial applications, and nylon is pelletized for further regeneration. The nylon is shipped to Aquafil's facility, where depolymerization transforms waste into regenerated nylon, chemically identical to virgin material, ready for use in textiles, flooring, and design applications. Recycling may begin with a simple act, placing waste into a bin, but what follows is a sophisticated and highly coordinated process. From collection to transformation, each step is designed to recover value from discarded materials. The journey starts when recyclables are gathered through curbside programs, drop-off centers, or commercial services. Once collected, the materials are delivered to a material recovery facility, or MRF. These facilities, often covering several thousand square meters, are the nerve centers of recycling, sorting up to 400 tons of waste each day. Inside, the process begins on the tipping floor, where trucks unload their cargo. Here, contaminants, such as hazardous items or oversized debris, are quickly removed. Materials then move onto conveyor belts, where both manual labor and advanced technologies take over. Rotating screens separate items by size, powerful magnets extract steel, optical sensors distinguish plastics by color and resin type, and air classifiers lift light paper from heavier glass and metal. Despite automation, human workers remain vital, ensuring accuracy and removing unwanted materials. Once sorted, recyclables are compacted into dense bales, blocks of paper, cardboard, plastics, or aluminum, ready for shipment to specialized processing plants. There, each material follows its own path. Paper is pulped and cleaned for reuse. Plastics are shredded and melted into pellets. Glass is crushed into cullet for remelting, and metals are smelted into ingots or sheets. These processed materials become raw inputs for manufacturers, feeding back into the production of everyday goods. Not everything, however, can be saved. Around 60% of what enters the bin is non-recyclable. Some of this residue is diverted to landfills, while other portions are incinerated in waste-to-energy plants, generating power but also posing environmental challenges. Recycling's impact goes beyond waste diversion. By conserving virgin resources, reducing greenhouse gas emissions, and lowering energy consumption, it plays a critical role in building a sustainable future. Yet, the system relies on more than technology. It depends on conscious participation. Every choice to reduce, reuse, and properly sort materials strengthens the recycling loop. So while not all waste can be recycled, every effort counts. Each item returned to the cycle moves us closer to a cleaner environment and a truly circular economy. The PET bottle recycling plant in Karad, designed by Suraj Engineering, is a state-of-the-art facility dedicated to converting post-consumer PET bottles into reusable raw materials. Upon arrival, bottles are first collected and pre-sorted to remove contaminants such as caps, labels, and non-PET materials. The clean bottles are then shredded into uniform flakes, ensuring consistency for the downstream processes. These flakes are thoroughly washed using advanced washing systems to remove dirt, adhesives, and residues. After drying, the PET flakes are further processed through quality inspection and sieving to achieve the desired size and purity. The final high-quality PET flakes are ready for manufacturing new bottles, packaging materials, or polyester fibers. The plant emphasizes efficiency, sustainability, and environmental responsibility, helping reduce plastic waste while supplying industries with recycled PET materials that meet global quality standards. Designed to combat one of the greatest environmental challenges of time, this autonomous surface drone removes algae, floating biomass, and plastic waste before they choke fragile ecosystems. Shaped like a catamaran, it collects debris and biomass on the water surface into its onboard waste basket, which is emptied at docking stations. Zero carbon emissions are produced during operation, and the drone can run for long periods, often up to 8 to 10 hours per deployment. It navigates via GPS waypoints and can follow manually guided or preset routes. Optional sensors such as LiDAR water quality probes equip the system to monitor environmental data in real time. At Renew E, more than 600,000 tons of paper and cardboard are collected and transported to specialized sorting facilities. Non-paper materials are removed, and paper is separated by type and quality. Confidential documents are securely shredded. The material is pressed into 400-kilogram bales, then sent to manufacturers to produce new paper products efficiently. The Seabin at Marina Muderzand operates as a floating collection system, using an electric water pump to capture surface debris. Floating plastics, including bottles, bags, cups, and microplastics, are drawn into the bin, while aquatic life remains unaffected. In 1 year, a single Seabin can capture 83,000 plastic bags and 20,000 bottles, totaling half a ton, all of which is sent for recycling. Ontlies, that's honeymoon. The Glutton 2411 electric waste vacuum cleaner transforms modern cleaning with precision and efficiency. Its 75 centimeters nozzle, dual suction speeds, and self-propelled system reach tight spaces effortlessly. A 240-liter hygienic container with automatic disinfectant spray prevents dust and fire risks. Silent, powerful, and terrain adaptive, it handles all debris, redefining urban and industrial waste management. Engineered for precision, the Aristirma Conveyoru redefines recycling automation. From industrial belts to modular and flexible chain conveyors, it ensures uninterrupted material flow, durability, and adaptability, driving efficiency across industries and transforming the future of automated waste separation. In today's era, artificial intelligence is shaping every industry, and recycling is no exception. As materials arrive, oversized or non-recyclable items are first removed, preparing the stream for precise processing. Conveyors carry the waste under advanced optical sensors and high-resolution cameras. AI algorithms analyze every piece, distinguishing plastics, cartons, and composites, even by color and material type. Air jets and robotic arms then direct each item into its designated bin, ensuring purity and efficiency. The system constantly learns from the data, optimizing performance with every pass. This intelligent approach accelerates sorting while reducing contamination, creating high-quality recycled materials. From everyday packaging to complex composites, nothing goes to waste. By combining cutting-edge technology with sustainable practices, this facility sets a new standard for recycling, turning discarded materials into valuable resources, and proving that innovation can lead the way to a cleaner, more efficient future. The journey of automated textile recycling begins with pre-sorted post-consumer garments, carefully prepared for processing. In the first stage, the textiles enter an automated distribution and sorting system, where advanced sensors and scanners classify them by color and fiber composition. Once organized, the materials are tightly baled for transport and storage. The process continues with a purification stage, where prepared materials are further refined. Here, sorting is repeated with greater precision, followed again by baling into uniform fabric clips. In the third step, all non-textile disruptors such as buttons, zippers, and plastics are removed, ensuring only clean, usable fibers remain. Finally, the textiles move into the mechanical recycling stage. Shredded into fibers, the material is transformed into valuable resources ready for reuse. These recovered fibers find new life in non-woven fabrics, spinning yarns, chemical recycling, and composite compounds. Through automation, textile recycling becomes faster, cleaner, and more sustainable, closing the loop for a circular economy. The Bosheng S2 Urban Diesel Compact Road Sweeper represents the next level of smart city cleaning. Designed for efficiency and sustainability, it delivers up to 30% fuel savings and produces 30% less carbon dioxide emissions, making every sweep cleaner and greener. Its 15 centimeters narrower body and 1,000 kilograms lighter weight ensure perfect urban integration, allowing it to navigate tight streets and crowded areas with ease. The articulated and agile design, combined with oscillating suspension, guarantees stability and precision on uneven surfaces. The Bosheng S2 isn't just a machine, it's a symbol of innovation, harmony, and performance, built for the heartbeat of modern cities. Have you ever wondered where old appliances, bicycles, or scrap metal truly go after disposal? The answer is transformation at Cozy Recycling. Cozy buying, sorting, and recycling all grades of ferrous and non-ferrous metals. Inside the Bellwood warehouse, more than 100 varieties of non-ferrous materials, such as aluminum, brass, copper, and stainless steel, are carefully processed. A modern scale system photographs and records every load, ensuring transparency and traceability. In the steel yard, obsolete materials like appliances and beams are shredded or sheared, then prepared to exact mill specifications. Advanced eddy current technology separates metals from non-metallics, while dust control systems protect both workers and the surrounding environment. Supported by a GPS-monitored transport fleet and custom container services, Cozy Recycling ensures scrap is collected, processed, and repurposed efficiently, turning yesterday's waste into tomorrow's resources. press, or compression processing, is one of the most striking steps in the metal recycling industry. In this process, an entire car, stripped of hazardous fluids and reusable parts, is placed into a powerful hydraulic press. With thousands of tons of force, the press compacts the vehicle's frame, crushing it down into a dense, uniform cube or rectangular block. This compression dramatically reduces the volume of the scrap, making storage, handling, and transportation far more efficient. Once compressed, these metal cubes are loaded and shipped to steel mills or recycling plants. There, they are melted down and refined into raw material ready for new manufacturing. What once was a discarded vehicle can return as steel for buildings, machinery, or even new automobiles, completing the recycling loop. At any scrap car, every vehicle begins its final journey with precision and care. An industrial excavator equipped with powerful metal grabs lifts and moves the car into position. Fluids, such as fuel, oil, and coolant, are safely drained to prevent pollution. Next, reusable parts like engines, wheels, and catalytic converters are removed for resale or recycling. The stripped shell is then transported to a hydraulic crusher, where tons of pressure flatten the car into a dense slab or cube. Finally, the compressed metal is sent to steel mills, ready to be melted and reborn into new products. The M&J 4000M is a heavy-duty mobile shredder engineered for automotive recycling. Equipped with twin 2-meter shafts and robust steel knives, it delivers up to 264,000 Newton-meters of torque, making it capable of shredding complete cars, including engines and chassis, with controlled precision. Processing capacity reaches up to 60 tons per hour, depending on input material. Cars are fed into the 4,000 millimeters cutting chamber, where they are fragmented into recyclable fractions of steel, aluminum, and non-ferrous metals. Mounted on tracks for mobility, the M&J 4000M combines hydraulic power, advanced control systems, and field flexibility for efficient end-of-life vehicle recycling. At Ash Pallet Management Inc., the recycling of wooden pallets is carried out with precision and efficiency. Incoming pallets are first sorted and graded, then dismantled using state-of-the-art robotic systems for accuracy and material recovery. Usable components are repaired or reassembled, while damaged wood is recycled into cores for new pallets. Each unit passes through cutting, edge trimming, surface treatment, and stamping to ensure consistency and durability. With over 250,000 square feet of indoor storage and a dedicated fleet, operations maintain speed and reliability. The result is a continuous supply of high-quality, eco-friendly pallets ready for industrial use. At Bose Pallets and Mulch Inc., recycling begins the moment pallets arrive at the facility. Unloaded and directed to one of 16 repair stations, each pallet is carefully inspected for damage. If repairable, broken deck boards are replaced, restoring the pallet's structural integrity. Scrap wood removed during repairs is fed onto an overhead conveyor, where it makes its way to the grinder for recycling. The company processes nearly 2 million pallets annually. Repaired pallets move to the automated sorting station, each fitted with a barcode identifying size and condition. High-volume pallets are stacked automatically, while lower-volume pallets are stacked manually, With pallet track software, every pallet is monitored throughout the process. Pallets beyond repair are sent to robotic dismantlers, 2 of only 15 in operation industry-wide. Using handheld scanners, dismantled materials are tracked before reaching the urban saw system. Here, each board is electronically scanned, measured, trimmed, and sorted with precision, later reused to construct custom pallets of varying sizes. All remaining scrap wood enters the rotochopper grinder. A cross-belt magnetic conveyor extracts metals, while processed wood becomes boiler fuel, or premium mulch. The mulch can also be colorized, creating a sustainable, value-added product.